Hi, my name is Arvinder. This is my assignment 2 for machine learning. In this, first we import libraries, few libraries such as Pandas, NumPy, Matplotlib, Seaborn, sklearn, and after that we load our diabetes dataset and see the first 5 rows of our diabetes dataset, and there are total 11 number of columns in our dataset like age, sex, BMI, BP, S1 for total serum cholesterol, S2 like that, and target measure of disease progression 1 year after baseline. After that, we do the EDA of our data set where we can find summary statistics like count, mean, median, and the quartile range values. And also we can check that if there is any missing value in our data set, but there is no any missing value in our data set, then we create an histogram for each feature to analyze their distributions. It shows varied distributions, providing insights into their ranges. Features like age, BMI, and S5 follow relatively normally distribution, and the binary nature of sex feature is evident from its histogram. Overall, the features are well distributed, making them suitable for regression analysis. After that, we created a correlation heat map to analyze correlation between features and the target variable. Here, in the correlation heat map, features such as BMI and S5 have strong correlation with the target, indicating their high predictive importance. Here is our BMI, which is 0.59, and S5 is 0.57. S3 shows a negative correlation with the target, suggesting an inverse relationship with the diabetes progression. And features like S1 and S2 exhibit strong intercorrelations between correlations, but weaker relationship with the target, hinting at potential multicollinearity. After that, we did stratified random sampling. It was performed by dividing the target variable into 4 quartile-based categories using PDQ cut. After that, we did reserved the testing data to 10%, ensuring the distribution of the target variables remain consistent between the train and the test sets. Here, our random seed is 17 because my student ID is 300200517. This stratification sampling ensures that the test set is representative of the overall data set, reducing bias in model evaluation. Then we did the linear regression. Here our linear regression train root mean square error for the trained data is 22 and for the test is 24.79. So linear regression provides stable result with minimal overfitting or underfitting. Then we did ridge regression. Here our value is 22 for train, test is 23. Shows it slightly reduce overfitting by introducing regulations compared to the linear regression. And for the polynomial regression for degree T3, and then we did for the degree 5. For the degree 3, the train is 7. And for the test is 349, which is quite high. The model overfits the training data as indicated by the significant gap between train and the test root mean square error. And for the degree 5, the overfitting is too high due to its highly complexity. Then we did the nonlinear regression SVR, support vector regression. Here our value is 60 for the train and test is 62. It underfits the data, possibly due to default hyperparameter settings. And then we did the random forest regressor. Here our root mean square error value for the train is 8 and for the test is 22.5235. Random forest achieves the best balance, effectively handling non-collinearity without overfitting. Then we just print the overall result for our model for the linear ridge polynomial regression under degree 3, under degree 5. Then we did SVR random forest. And for the question number 10th, report and discuss the performance of different trained model. Do you see any overfitting or underfitting? Yeah, for the overfitting, we have seen that polynomial regression degree 3 and 5 overfits the training data as evidenced by low train RMSE and high tests RMSE. Underfitting, we see underfitting in SVR, sport vector regression, with high RMSE on both train and test sets. And we see the balanced model, which are linear ridge and random forest model, provide better generalization with minimal overfitting or underfitting. Move to the question 11, report and discuss the performance of linear and non-linear regression model. The linear model, linear and ridge regression, provides stable, interpretable results and are less prone to overfitting but unable to capture complex relationships. And for the nonlinear model, polynomial regression demonstrates the risk of overfitting with high complexity model. Sport vector regression underperforms, likely due to the suboptimal parameter tuning. Random and whereas random forest strikes a balance, capturing nonlinear patterns effectively without overfitting. And for the question 12, discuss approaches to improve the performance. So here are so many feature scaling, hyperparameter tuning for ridge regression, for SVR, fine tuning C, kernel parameters like that.